Just before we start off the video, I just want to quickly ask you to subscribe if you like this video, and also hit the bell icon if you want to get notified of any new videos we post. Thank you. Keep watching. Bye. Hello everyone, welcome back to another video. So in this video, we're going to quickly cover another simple topic around how many indexes are too many indexes on your table. So this is a very interesting topic, and also quite relevant when you're actually tuning your application. So, it's easily the most important question, because let's take an example where you're tuning your application. You're saying, okay, this particular sort of procedure actually is taking a lot of time to query the database and return back the results. Okay, so that's a common scenario. Now, when you go into the details, you try to find out, okay, which query within that your stored procedure is actually taking too long. Obviously, when you get to the conclusion saying, oh, it's this query which is actually saying, taking, probably 10 seconds, whereas all the other queries within that stored procedure are probably returning within a millisecond. Obviously, that's an example. 10 seconds might not be an issue for your application, but let's take an example that 10 seconds is an issue. So you want to reduce that 10 seconds back to probably a second, or even a less than a second. So there's obviously two different things you look at. So one, I'm querying on this table. Is it doing a full scan, which basically means, is it actually doing a scan rather than a seek on an index? So if you have an index, obviously it's much faster. However, that's not the immediate solution you need to get to. So you might actually have indexes on your table already. So you might need to consider, can I actually modify this query to use some of the indexes that I already have? However, that might not be a possibility, and you might actually end up creating indexes. However, the problem is, when you create too many indexes on your table, you might actually slow down your inserts, updates, or deletes, and therefore the overall experience from your application might degrade because of that one index you might add. So that's why it's a very interesting topic, and it's very important to understand that it's not always good to create a new index. Okay, so in that, so how do you know then, in that case, when to create, when not to create? So let's take a look at two different examples. So consider your application is primarily focused on reading the data from your database. Okay, so you have, for example, this customer table, and let's take an example saying, okay, this has a few 100,000 or a few millions of records. Yeah. And your primary objective is to basically query on the table. And obviously, you want to either search on customer name or email address or postal code, etc. Yeah. And since your primary objective is reading the data from this table, and your primary objective is not writing data to this table, you can actually say, oh, I can actually have indexes, because I'm not going to do that many inserts into this table, or that many updates, or that many deletes into this table, and therefore I'm not actually degrading the performance. So yeah, so as you see what I'm trying to get at, isn't it? So you need to look at the primary objective of your application when it comes to this table. Yeah. So you get to a conclusion that you need an index on customer name. So that's fine, because your primary objective is only reading the data. You can actually say, okay, that's fine, I'm going to add. And because you're not actually writing, a large amount of data, or continuous or frequent updates or frequent inserts or frequent deletes into this table, you're actually comfortable, and you should be able to create an index and be happy with it. However, if flip the coin there and then say, actually, your application is primarily focused on writing data into this table, which means you're frequently updating, you're frequently inserting, or frequently deleting data from this table, then it's a completely different picture. So, don't get me wrong. I'm not saying if you frequently update, don't create index at all. You need to create index, but you need to be clever at it. Okay, so if you have for example, a primary index is what you always will have, a clustered index. And you might actually say, okay, I'm going to add an index on the customer name. So if your primary objective is frequently inserting and writing data to this table, having too many indexes will obviously degrade the performance. So you need to cut down on the number of indexes, and you need to look at your table structure on a whole. So one thing you need to say is, okay, I'm able to search on the customer and basically either use the date of birth or the customer name as the other index on this table, which is fine. And obviously, if you have, for example, in this case, you have 1, 2, 3, 4, 5, 6, 7 columns. And you might actually have an application which is searching on all these 7 columns, okay, which is a bit extensive when you have like millions of rows. So you need to also consider, actually, customer is actually having an address, but the difficult thing here is, I'm having the address on the same location as the or the same table as the customer. So you can have millions of customers, but not necessarily the same amount of houses. So you need to consider, from a functional point of view, have I actually considered the table structure correctly? So what you might actually decide to do is, okay, if I want to search on the postal code, I need to put the address on a different table, and that will cut down the number of rows immediately for the postal addresses. And if whenever you're searching on addresses, you might actually say, okay, go into that table and query the address. And from there, I can actually have a link table which goes back and searches in the customer, say, to find all the customers linked to that address. So you need to obviously think on a high level these objectives, and obviously don't just look at that one query that's delaying your SP store procedure and say, oh, I'm going to create an index. So, this is one thing you need to keep in mind. And obviously, if you find yourself in the scenario, you know now what to do, because you need to look at, one, is my application read sensitive, or is my application load or write sensitive? So if you figure out any of these two from your table point of view, and then you can drill down and, either modulate your query to suit your existing indexes, or if your application is more read sensitive, you might actually decide, okay, let's create an index for this table. The other thing you might also think about is, I might actually create an index anyway on this table, but you need to obviously, even though your application is write sensitive, but you also need to say, okay, let me run some regression tests on this so that I have not actually degraded the performance of this application on an overall basis. So, there's sometimes trial and errors you need to do in these cases, but in the end result is, you shouldn't actually degrade the performance of your application. So keep that in mind. Okay. I hope you found that whole explanation useful, but if you have any questions, please write your questions in the comment section below. And if you have any other topics you want me to cover, please also, write them in the comment section below. If you like this video, please hit the like button. And if you are happy to see all these videos and you're excited about the latest technologies, then please subscribe and hit the bell icon. And thank you very much. Peace. Goodbye.